Hello again, Math 20-1s. In today's lesson, we're going to look at solving some more quadratic equations. Again, quadratic equations are ones that have a degree of 2 in them, which typically fall into our trinomials that can be factored using various methods. I want to keep this lesson separate from the first part of lesson number 5, just because I do find that students struggle a bit more with setting up and solving word problems. So I just wanted to treat the zero product rule and the word problem solving as two distinct things. All right, so here's some general guidelines of how to set one of these word problems up. Typically, in one of these problems, there's going to be some unknown quantity that you need to solve for. Sometimes it's one unknown quantity, sometimes it's two of them. You need to pick some variables that are going to represent those unknown quantities. 2, you form a quadratic equation from the given information. So again, typically what we're looking for in this lesson is the quadratic equations we eventually want to get to are the ones in the trinomial form that are ax squared plus bx plus c is equal to 0. And then we can factor that trinomial, and the solution to the equation is just going to be by taking each factor and setting them equal to 0 for using the zero product rule and just solving for x. Step 4 says state the solution to the problem. We'll just do that just by simply identifying what the value of the variable is. We don't need to write down a complete sentence identifying like what the solution to the problem is going to look at. These problems are, fairly simple. They're geometry problems. We'll look at some more complicated word problems a little bit later on when we revisit this again in the unit that's going to focus solely on quadratic equations and relations. Okay, so start off with this one. It says we have a rectangular sheet of paper, which I'll just quickly sketch. Okay, the rectangular sheet of paper has an area of 300 centimeters squared. I'm going to use the variable a to represent the area. So I'll say let a equal the area. Now we actually know what this number is. It's 300 centimeters squared. For the time being, I'm just going to drop the units. At the end of the problem, we can put the units back in. Okay, it says the length is 5 centimeters more than the width. Now, that doesn't actually tell you what the length of the width of the rectangular sheet are. So we need to treat both of those as variables. So I'm going to let L equal the length. So that's one unknown. And W equal the width. I'll label this on this picture. So this would be the length. This would be the width. Okay, so based on the second sentence here, I'm going to form one equation. So it tells me the length is 5 centimeters more than the width. So this would be your length is, I'm going to replace it with an equal sign, 5 centimeters more than the width. So it would be 5 plus W. Just for now, I'm going to box this equation. I'm going to call it equation number 1. We're going to make use of it in a moment. So I'll say EQ apostrophe N 1 for equation 1. Form a polynomial equation and solve it to determine the perimeter of the rectangular sheet. If we want to get the perimeter, we need to know what both the length and the width are. Then we can add all the outside lengths together to get the perimeter. Okay, so we're going to use an equation that makes use of area, length, and width. And we should know this. The area of a rectangle is the length times the width. Now, what I'm going to do is I'm going to make a couple of substitutions in this equation. So first of all, in the place of area, I'm just going to replace it with 300. And in the place of length, I'm going to replace it with this mathematical expression, 5 plus W. If you go ahead and do this, it would then give you 300 is equal to 5 plus W multiplied by the width on the outside. I'm going to expand this equation to get rid of these brackets. So I'm going to do that by applying the W to both the 5 and to this W on the inside. And then this would give me 300 is equal to 5W plus W squared. I want to get it into a trinomial in this form up here. So I need to move all the terms over to the same side. So to do that, I'm just going to subtract 300 from both sides of the equation. So I'll minus 300, and we'll subtract 300. And then this would give me a trinomial quadratic equation that is, we'll start the w squared term first. So it'll be w squared plus 5w minus 300 is equal to 0. We can factor this equation using inspection. So I'll set up my two factors. I need two numbers that are going to add to give me positive 5 and multiply together to give me negative 300. So those two numbers would be positive 20 and negative 15. I'll just tell you what those factors are right now. If you're doing this on your own, you might need to think about this a bit more and do some trial and error to figure out what the two factors are going to be. Okay, now to find the solution to the equation, we need to use the zero product rule. So I'm going to take this first factor. I'm going to set it equal to 0. And I'll take the second factor and also set it equal to 0. So the first factor would be w plus 20 is equal to 0. And then if you manipulate for w, it would be w is equal to, you'd subtract 20 from both sides of the equation. So it'd be w is equal to negative 20 centimeters. Okay, we can add the units back in at the end now. Now, this can't be this isn't an actual solution, because when you're looking at the width of an object, you can't have a negative width. It doesn't have any physical meaning. So immediately I'm just going to get rid of this. Okay, that's not going to be one of the solutions. Cannot have negative width. The second one, I would have w minus 15 is equal to 0. And if you isolate for w, just add 15 to both sides of the equation, and you get w is equal to 15. And we can add the units in here, 15 centimeters. Positive width, that's okay. Now, I also want to get the length before I calculate the perimeter. So to get the length, all we need to do is we're going to take this value of w and sub it into equation number 1. So I'll sub w is equal to 15 centimeters into equation 1. Okay, so we'll do this substitution. And once again, we're going to drop the units just for the time being. So this would then be L is equal to 5 plus 15. And that would be my length is then equal to 20 centimeters. Okay, now that I have the length and the width, I can figure out the perimeter. So suppose we could say let P equal the perimeter. The perimeter of this rectangle would be 2 times the length plus 2 times the width, okay? Because you have two sides that are the lengths and you have two sides that are the widths. We can actually simplify this just by pulling out a common 2. So the perimeter would just be 2 multiplied by the sum of the length and the width. Plug these numbers in now. It'd be 2 multiplied by L is 20. Again, we'll drop the units just for the time being. Plus W, which is 15. Order of operations, we do it in brackets first. So 20 plus 15 would be 35. And then multiply by 2, and we would get the perimeter, which would be 70 centimeters. Okay, so you start off by introducing variables, and you kind of read through the problem to like build some equations. And then based on the equations you build, you're going to eventually get a quadratic equation in that trinomial form, factor it. Most likely going to have to use the zero product rule to solve it. And then you can get whatever solution to the word problem you're looking at. Let's look at one more here. So the diagram shows the cross section of a water trough whose sloping sides AD and BC make angles of 45 degrees at the horizontal. And it tells me the length from D to C is 36 centimeters. Okay, so it says show that the area of the entire cross section is x and then 36 minus x. Okay, so the way I'm going to do this is I basically need to figure out the area of this large trapezoid, and I'm going to break it into a bunch of smaller sections. So I'm going to break it into one rectangular section. So we'll call this area 1. It looks like this. And you've got these two triangular sections on the side. So I'm going to call that section number 2. This triangular section is actually the same thing, just because they both make a 45-degree angle at the horizontal. So this would also be area number 2. Now, before I attempt to figure out what the area of these individual shapes are, I need to know a couple of dimensions of this water trough. So specifically, the first thing I need to know is I need to know what this distance is across here. So the horizontal distance from, I don't know, point D to like where A is located, if you just go straight up from A. So I'm going to call that, let's call that length B, okay? This will actually be the same thing as this length as well. This will also be length B. Now, to figure out what that is, we need to use some basic trigonometry, but nothing too complicated. So I'll just draw the triangle over on the side here. Okay, so that's a 45-degree angle. Now, we know this side length is side length X, and this is going to be B, the side we're going to try to figure out. Some of you may already be able to look at this and know what side length B is going to be, but I'm just going to expand upon it a little bit. So when I'm dealing with a right angle triangle, I want to identify my opposite, adjacent, and hypotenuse sides of the triangle. So this is a right angle triangle. So side opposite is the side that's opposite from the angle. So this is side opposite. We'll call it OPP. And then the hypotenuse is the longest side of the triangle. And then this side here, where you kind of just make like a little turn to a shorter side from the angle, that's what we call the adjacent side. Now, the trig ratio I'm going to use here is, I know the angle, I know the opposite side, I want to find the adjacent side. So I'm going to use the tangent ratio to figure out what length B is. So I'd have tan of, let's say tan of, well, let's give myself more space here. Okay, I'd have tan of 45 degrees would be equal to side opposite over side adjacent. Okay, let's replace opposite and adjacent with the variables we have here. So I'll say tan of 45 degrees would be equal to x divided by b. Okay, we're going to solve for b. I'll just pull it over here to do it. Now, the way to do this is we can just quickly cross multiply. So I'm going to take the b and the tan of 45 and just make them switch spots. So when I do that, I would then get b is equal to x divided by tan of 45 degrees. Now, it turns out that tan of 45 degrees, if you actually plug that into your calculator, tan of 45 degrees is actually equal to 1. If you plug tan of 45 degrees into your calculator, now you do need your calculator to be in degrees mode for this to work. So you may have to click the mode button and switch the angle from radians to degrees. And then if you plug in tan of 45, it would just be 1. So that means that b would be x divided by 1, which just tells you that x is equal to b. And again, that's kind of a pretty obvious result. This is a 45-degree angle. It just means that side opposite and side adjacent are the exact same length. So it turns out that b is going to be equal to x. Okay, b is equal to x. Now I need one more side length here. So I need to know the distance from A to B. Okay, so the way I would do this is this full horizontal length from D all the way to C is 36 centimeters. So what we're going to do is we're going to take 36 centimeters and we're going to subtract these two horizontal lengths B. So this would actually end up being, take the full length, which is 36, and I'm going to subtract 2 of these horizontal lengths on the side here. So 2 of these B lengths, which would be subtract 2 x's. So that's going to be the length of this rectangle in the middle. Okay, so let's calculate the total area. So the total area, so I'll say A total, ATOT, would be equal to area 1 plus 2 times area 2. We have 2 of these triangles. Okay, this would be equal to, so the area of this rectangle is going to be the length times the width. So the length of it is 36 minus 2x. And then we're going to multiply by the width of the, we can call it base and height. So like it's base times height. So the base is 36 minus 2x. The height is x. And then plus 2 times, okay, the area of a triangle is base times height divided by 2. So the base is x. The height is also x. So x times x. And then area of a triangle is base times height divided by 2. Okay, we can simplify this a little bit right away. I've got a 2 on the top here, 2 on the bottom. Those will just cancel off. And now I can start to simplify this. So we'll use the distributive property to bring this x in. So then this would give me my total area is equal to 36 36x okay, 36x minus 2x squared. So that's the area of the rectangle. And then we add the area of the two triangles, would be adding x squared. Okay, so then that would give me my total area would be equal to combine like terms. We'd have 36x, and then negative 2x squared plus x squared would be negative x squared. And then we just would factor out the common x. And now we get a total is x, and then 36 minus x. And we can add the units at the end here. We're dealing with area, so it'd be square units. And since we're dealing with centimeters, it'd be centimeters squared. Okay, so that's a simplified expression for what the area of this would be. Now we got one more part to do. So it says if the area of the cross section is 260 square centimeters, determine what the value of x is. Okay, because yeah, x is an unknown length dimension that we don't know right now. Okay, so let's go back to my equations. The equation we just got was your total area is equal to x and then 36 minus x. Okay, the total area we can replace with 260, and that would be equal to, I'm also just I'm gonna expand this again, because I'm kind of undoing what we just, so the previous part we factored out, now we're gonna go back and just undo it by expanding again. So this would then be 36x minus x squared. Now, to get the quadratic set up to solve, we need to get all the terms on the same side. And I also would like the numerical coefficient in front of the x squared term to be positive. So I'm going to add x squared to both sides, add x squared. I'm going to subtract 36x, subtract 36x. Okay, and then this would be x squared minus 36x plus 260 is equal to 0. Okay, this can be factored through inspection. So I need two numbers that add to give you negative 36 and multiply to give you 260. I'll just simply list what those numbers are off to you. Again, if you did this, you might need to do a bit of trial and error. Okay, so the two numbers would be negative 26 and negative 10. So you have x minus 26, x minus 10. Okay, and that's equal to 0. So now I use the zero product rule, which is I'm going to take this first factor and set it equal to 0. I'm going to take the second factor and set it equal to 0 and determine what the value of x is. So the first one would be x minus 26 equals 0. If you add 26 to both sides of the equation, you get x is equal to 26. And we'll add the units back in now. So that'd be centimeters. So that's one solution. As long as it's a positive number for a length, then you're fine. And then the second one would be x minus 10 is equal to 0. So we're using the second part of that zero product rule. Add 10 to both sides of the equation, and you get x is equal to, that should be x minus 10 is equal to 0. Okay, and then you add 10 to both sides of the equation, and you get x is equal to 10 centimeters. So it turns out there's actually two solutions here. The value of x could either be 26 centimeters, or it could be 10 centimeters. Two possible solutions. If one of them was a negative number, then you would discard it. Okay, so you can finish this lesson off by completing, in addition to the problems I've assigned before, so this would start on page 262. Do numbers 5 and then 7 through 10. And I'll talk to you in the next slide.